This lesson is about the three temperature scales that we use and how to convert between those three temperature scales. Here in this country, we are most familiar with Fahrenheit, which I'm not even sure I can spell. I think it's Fahrenheit. That's close enough. So Fahrenheit, who uses it? The U.S. uses it, and I don't know of anybody else. There's probably some tiny country somewhere that use Fahrenheit, but pretty much it's just the U.S. Most of the world uses Celsius. So Celsius, rest of world. So you know my opinion on the metric system, and you know it's just another example of the U.S. being, I guess, dragging its feet. So anyway, the Fahrenheit scale. Where does it come from? It was developed hundreds of years ago, I think in Germany, and I think the guy's name wasn't actually Fahrenheit who came up with it. I think it was Romer. But anyway, what he did was he chose as his zero. His zero was the coldest temperature it ever got where he lived. Okay, well, he lives, you know, in a country that's not the same as ours, so it gets colder here or warmer there or whatever. So his temperature scale, it was kind of arbitrary. On his scale, the water happens to freeze and melt at 32 degrees. Water boils at what I think it's 212 degrees. Just these are some wacky numbers to remember. They're no fun to remember. The Celsius scale is a little bit nicer because water freezes or melts at 0 and boils or condenses at 100. Very easy to remember. You know, 0 and 100, that's it. How many kids come into my room and can tell me that water boils at 212? Very few. A lot of them can tell me that water freezes at 32 because we hear that, you know, on the weather all the time. But just looking at these two numbers, you can see that this is the way to go. So how can we convert back and forth between these two? Well, it turns out, I mean, if you look at this kind of commonsensically, between, let's see, water freezes here and there, and water boils at here and there. So in between these two is a space of 100 degrees, and in between these two is what? Something like 180 degrees. So that means that Celsius degrees are bigger. So since a Celsius degree is bigger, if you listen to the radio or the news and you happen to hear them giving temperature predictions in like Canada, let's say, they'll say, well, the high today is going to be from 20 to 22. And you're like, wow, that sounds really precise. You know, when we hear the weather, they might say the temperature today is going to be from 60 to 65 or something like that. Well, the reason why is because Celsius degrees are bigger. If that doesn't make sense to you, raise your hand right now and we'll pause the video for a second. So next, I want to talk about converting back and forth between the two. So there is an equation that relates these two. It's a linear type of equation, and here's what it looks like. It looks like this. F equals 9/5 C plus 32. So this equation right here, if you know C and plug it in, put in the number for Celsius, it will give you the Fahrenheit temperature. So let's see. Could we get C by itself? Yeah, we could. We would subtract 32 from each side. So let's actually do this. So F minus 32 equals 9C over 5. Let's get rid of this divided 5 here. We'll multiply by 5. When we do that, it goes away, but whatever we do to one side, we got to do to the other. So we get, let's see here, 5F minus, oh shoot, can I do that in my head? 30, 60, 90, 120, 150. No, I can't do it in my head. Is 160 equals 9C. So now we want to get rid of this multiplied 9, so we'll divide both sides by 9. And what do we wind up with? We wind up with this. C equals 5/9. Why did I write it like that? 5/9 F minus, and then 160 over 9 is, I think it's 17, yeah, 17.7 repeating. So this equation right up here will get you F if you know C, and this one will get you C if you know F. Really, I mean, you don't need to know both of these. If you just know one, you can plug in, you know, F or C and get the other one by itself. So that's pretty easy. So both of these temperature scales, they do have one inherent weakness, and it's kind of a big deal. It's a big problem for us in physics. The weakness is that both of these scales cross over from let's switch colors here. They cross over from 0 and into negative numbers. What do I mean by this? What's the actual problem? Well, let's just say that you've got some equation in physics. Let's say you want some answer, and you've got to take some constant and multiply it by, I don't know, some number, and it gets divided by a temperature. Well, right now, hopefully you can already see what the problem is with these two temperature scales, because if you take 0 Fahrenheit and put it in here for T, or 0 Celsius and put it in there for T, what does your answer become? I don't know. I mean, you're trying to divide by 0. You can't do that. So that is a big problem with these two temperature scales. So the big point here is, I guess in my mind, is this scale is the worst one. This scale right here is better, but there is a temperature scale that's even better, and it is called the Kelvin scale. And this scale doesn't have a 0 that can mess up our math. Let's take a second and let that sink in. Maybe you have a question about that. So the Kelvin scale, I said something that just sounds wrong. It doesn't have a 0. Well, you guys are old enough that you've probably heard of this thing called absolute 0. And that's this temperature where all particle motion would cease. So if you had a proton or an electron or something, at this temperature, it wouldn't be moving at all. And it turns out that that's actually, I don't want to say a myth, but it's actually just a concept, because you can't ever get anything down to absolute 0 because of quantum effects. The energy inherent in all particles has some motion, so you can never actually reach absolute 0. So in the Kelvin scale, you're never going to wind up with a 0 in a place in a fraction that can mess you up. So the Kelvin scale is, I guess it's just it's the best one that we have. It's the best temperature scale there is for us. So one nice thing about the Kelvin scale is that a Kelvin degree is the same size as a Celsius degree. So the Kelvin temperature then is, absolute 0 is pretty darn cold. The temperature in Kelvin is the Celsius temperature plus 273. Okay, so if you have this equation here, let me get rid of this. So there you go, Kelvin equals Celsius plus 273. And this allows us to do lots more stuff in physics. So now would probably be a good time to solve a couple problems for you. So let's do this. Insert a new page here. So where's my old page? It's down here, right? Okay, so let's say that we go outside on a wonderful April day, and let's say that it's 28 degrees Fahrenheit. I want to switch that both to Celsius and to Kelvin. Which one am I going to do first? Obviously, I hope I'm going to do Celsius first, because I gave you guys these equations here, and we can only get Kelvin once we already know Celsius. So let's do that. Let's see here. Celsius equals, C equals 5F over 9 minus 17.7. So Celsius equals 5F over 9 minus 17.7 repeating. Okay, so all we got to do then is put in 28 right there. So I don't think I'm going to bother writing this down. I'm just going to do it. So let's hit clear here. We're going to go 5 times 28 equals divided by 9 equals minus 17 point. I'm just going to hit a bunch of 7s and boom. So negative 2.2. And I guess if you had a thermometer or you're listening to it on the radio, you wouldn't get the decimal anyway. So you would just say that the Celsius temperature is negative 2 degrees Celsius. Okay. So on a 28 degree day, of course, that is below freezing. And let's see here. Let's go back to our original stuff here. Water freezes at 32 in our scale, 0 in the Celsius scale. So it makes sense that a temperature of 28, which is a little bit below freezing, would be negative 2, you know, a little bit below freezing. And then lastly, I want to switch to Kelvin. So if I go back here and look, Kelvin equals Celsius plus 273. Okay, so Kelvin equals Celsius plus 273. I think it's actually like 273.15 or something, but I got to be honest, I never use that. So negative 2, throw that in here. I did that in red up there, but oh well. So this is going to be 271. And we don't use the degree sign for Kelvin. We just call it 271 kelvins. Yeah, there you go. So that is how you switch back and forth between Celsius and Kelvin and Fahrenheit. It's basically just some algebra. Let's just because I wanted to go 15 minutes or less, I've got a few minutes left. So let's do this. Let's say that we've got a really, really cold day. Let's say that it's negative 40 Celsius, and I want to know what that is in Kelvin and Fahrenheit. So let me see how quickly I can do this. So negative 40 Celsius. So if I want to know Fahrenheit, Fahrenheit equals 9/5 C plus 32. So 9/5 C plus 32. So let's get out my calculator as fast as I can here. Excuse me, and go, let's see, 9 times 40 negative is negative 360 divided by 5 is negative 72, so then plus 32, negative 40, really. So negative 40 Celsius actually is the same temperature as negative 40 Fahrenheit. Isn't that kind of nifty? So, you know, if you had a graph of the two temperature scales, they would actually, you know, cross each other at negative 40. And anyway, the last one, Kelvin. Kelvin is C plus 273, so negative 40 plus 273. And I know you guys are doing this in your heads because you have young brains, but let me, okay, I guess I can do it too. 270, 60, 50, 40, 30. So this is what, 233 Kelvin? And since I'm paranoid, I'm going to get out my calculator and do it. So 273 minus 40, 233, yeah. So there you go. That is some notes, some lecture, call it a focus lesson on the 3 temperature scales and how to convert between them, and you know who uses what and which one is the best. Kelvin.